Hello and welcome back Math 30-1. So to start off here today, we're just going to look at what each variable does when it comes to transformation of a function or the transformation of a graph. So right here, the absolute value of a, meaning it can't be negative, is the a right there. It's a vertical stretch, okay? Also, if a is negative, then it's a reflection of the x-axis. Okay, so let's take a look at the next one. Let's look at the h value. So when we subtract h is the horizontal translation. If h is greater than 0, the translation is to the right. That means x minus 5 is when h is 5 units to the right. If h is less than 0, that would be something like x plus 6, then we are translating it to the left. All right? Next one here we look at is, when we're looking at 1 over b, this is a horizontal stretch, okay? So this is, we stretch by 1 over b, that's the horizontal stretch. Because if we notice, b is where? With the x. The a here is on this side. If a is on that side, it's 1 over the absolute value of a. Okay? Also, if b is negative, then the reflection is in the y-axis. Okay, that's another thing to look at. Next one, k, is your vertical translation. Okay? Now, if k is greater than 0, the translation is units down. If k is less than 0, translation is units up. But remember, the k could also sometimes be on that side because it's y minus k is the same thing as plus k over there. Okay? And the order we always do this is stretches, reflections, translations, which is stinky, rotten tomatoes. Okay? All right, now, let's take a look at our very first example it has here. The graph of y is equal to f of x is shown right there. Okay, now consider the function defined by the equation. All right, now if the equation is written in the form of this, state the values of a, b, and h. Well, a is equal to 2. B is equal to 1 over 2. H is equal to negative 5. And k is equal to negative 8. Okay? Next it says, write the transformations associated with the parameters a, b, and h. Well, number 1 is a. A, right here, it's on the outside, is a vertical stretched by a factor of 2. About the x-axis. Okay, let's take a look at number 2. Number 2, b is 1/2. Okay, so that is, b is a horizontal, because remember that's with the x, is a horizontal stretch by a factor of 2. About the y-axis. Okay, and then now let's take a look at this. We're looking at h. H is a translation of 5 units left. H is okay, and the fourth one is k is a translation of 8 units down. Okay? All right. Now, put these information in an order which can be used to sketch the graph. So first thing we're going to do is my stretches. I'm going to start with my y stretches. So if we look at this, my vertical stretch goes from here to here. Okay? Everything is doubled. This will go there. This point here is going to go to 8. That's 4, so that goes to 8. 1 goes to 2. Here is 4. That's going to go to 8. And this stays the same. So my graph is going to kind of look like this here. There we go. Next is we want to do a Do the next stretch is a horizontal stretch. Okay, so everything doubles in distance away. So this is 1 away, so it must be 2 away. 1 away, 2 away. This stays where it is. This here is, 2 away, so now this is going to be 4 away. 1, 2, another 2. We have to double the distance. Double the distance. So now, my graph looks something like this. Okay? So we're done A and B. Next one is we're going to look at number 3. H is a translation of 5 units left. So now we have to look at 5 units left. So we're moving this whole graph, everything 5 units left. So that's going to go there. This one is 2 away from there, so we must go 2 away. And here, 2 away. Okay? This one must go 5 units left. 1, 2, 3, 4, 5. And this one must go 5 units left. So it's just going to be right there. So my new graph is looking like this. And then the last one says we have to move everything 8 units down. Okay? So translation of 8 units down. So let's take a look at my last one. This must go down 8 units. Right there. This must go down. Right there. This point down 8 units is right there. This point down 8 units is, what are we? 8? Oh, it's going to be there. This point here, down 8 units is there. So my new graph is going to look something like that. Okay, so there is your graph. Okay. Next part says the original graph has the equation y is equal to x squared. So the next one here, we have y is equal to x squared. So that's like saying f of x is x squared. So it says write the equation for the transformed function. So we're doing all of this to the function. So it was x squared. And this graph here, the original did look like x squared. If we look at it, it looks like x squared. Okay? So let's try this out. First of all, we know y goes to 1 over 2. We're always doing our stretches first. 1 over 2y. And we know x goes to 1 over 2x. All right? So what we end up getting is we're going to get 1, this here will give me 1 over 2y is equal to x over 2, or 1 over 2x squared. All right? Okay, let's continue. Now the next part here says, then we're going to go with reflections. Are there any reflections here? No, there are no reflections. So we also know then that x goes to x plus 5, and we know y goes to y subtract, or y plus 8. Okay? So I'm going to move this all the way to that side. So I have, first of all here, this will end up giving me y is equal to 2x over 2 squared. Okay? So let's take a look at this here. We're going to have to plug in this for y. So now we get, I'm going to leave that 2. Okay, so now let's replace this here for y. So we end up getting y minus 8 is equal to, and we have 2, and then we have, I'm going to leave that 1 over 2 here, and then we have x plus 5. And this is all squared. Okay? Now let's continue this out. We end up moving this 8 over to that side. So I get y is equal to 2. I'm going to have 1 over 2, bracket, x plus 5, bracket, bracket, squared, plus 8. Now if I solve this a little bit more, I'm going to end up getting 2, and we're going to get x plus 5 all over 2 squared plus 8. Okay? Now we could have also gotten another answer if we were following this and we want to simplify this out. because this ends up giving me y is equal to 2, and then we'd have x squared over 4, which gives me 1 over 2 x squared, right? Then we could plug back in, so here we'd end up getting y subtract 8 is equal to 1 over 2, and then we'd have x plus 5 squared, so then we'd end up getting y is equal to 1 over 2. Here we get x plus 5 squared plus 8. So this is another way of going about doing it, and essentially this is the same thing, because if we square this, this is all to the power of 4. We could square both of these and separate, so that would just break that out like that if we simplify our exponents. Okay, so there's a second way of doing that. Now let's take a look at this next one here. It says, the graph of f of x is shown. Sketch the graph of y, I'll just put an or here, of, so we know it's this or that. Okay, so sketch the graph of y is equal to negative 2 f of x minus 3 plus 1. Okay, so we have f of x here. So first thing, what do we want to do is do any stretches. Are there any stretches? I have a vertical stretch of 2. So we have a vert stretch by a factor of 2. Okay, so let's take a look at that. So if it's vertically stretched, this is going to be, if this is 4, this is going to be 8. 5, 6, 7, 8. So my new point should be there. Okay? And this is going to be up here, somewhere up there. And this stays. This is going to have to double, so that's going to be there. Okay? So my new graph is going to kind of look, I'm going to just do a dotted one, kind of like this. Okay, there we go. Then we have a flip, it's reflected in the x-axis. So we have a vertical reflection. So this goes down here to negative 8, which is down in there. Okay? So we have, this is there, so 8, 6, 7, 8. And this point stays. This point comes down here somewhere. Okay? And then this point is going to end up going up 4. So right there. So now my graph looks like this. Okay? Next, we have a translation of 1 unit up. Okay, so this is 8, and this was supposed to be 10. So 1 unit up. So it's going to go to here around. This point here moves there. Everything moves up 1 unit. This moves up. This moves up. And this moves up. And then we also get a translation of 3 right. So it's up and 3 right. So this one up and 1, 2, 1, 2, 3. So there's my new point. I'm going to put a big box on it. This one here moves up 1 and 3 right. 1, 2, 3. So let's put a big box on that. There's my new point. Now we have this point here moves up 1 and 3 right. 1, 2, 3. Put a big box on this one. And this point here moves up 1 and 3 right. 1, 2, 3. So it's going to be somewhere over there. So now if I graph this, my whole thing is going to look something like, oh, there's my first point there. And my whole graph is going to look something like this. And then it rounds. Oh, we forgot this point. Moves up 1, 1, 2, 3. It's going to be right there. And it goes like this. Okay? So that is kind of how my graph looks. And I'll put it in red. So it will look like that. Okay? And it goes down. So that is more or less how my graph is going to look at the end after all of the reflections and all the transformations. Okay? Let's take a look at the next one. It says, consider the function f of x. In each case, the replacement for x and y should be results of the following combinations of transformations. So the equation of the transform function of the form y is equal to like this. So a horizontal stretch by factor of 1/4. So we want a horizontal stretch of the factor of 1/4. Okay? So horizontal about the y-axis. So we know x is replaced by 4x. Okay? So b is equal to 4. So we have b is equal to 4. The next one, and a vertical translation of 5 units down. So k is equal to 5, negative 5. So my new formula is y is equal to f of 4x, bracket, subtract 5. Okay? Now the next one here, we're saying a vertical stretch by factor of 3 over 5. So y goes to 5 over 3. Okay? Y. And about the x-axis. Okay? Then we also have a reflection in the y-axis. So x goes to negative x. And a horizontal translation of 2 units left. So then x goes to x plus 2. So let's put all those in. So first of all, my a value here is equal to 3 over 5. Okay? Now my b value is equal to negative 1. And my x value is still x plus 2. So it's still going to be x plus 2. So when I put this in, we're going to get y is equal to 3 over 5. And then we're going to have f of, now we have negative, and then we're going to have negative 1, x plus 2, bracket. Okay? So instead of this negative 1, that negative is invisible. So I could just put negative like that. And that is all we have to do. And I'm going to put this both in brackets like that, just to close it off. So we know all of this is in the function. You could put a 1 there if you want, but it's not needed. So it's just 3 over 5, f, negative 1, x plus 2. And that's it. Now for this next one, we have x cubed is transformed to a new function p of x. To form a new function p of x, g of x is sketched vertically about the y-axis by a factor of 0.25. Okay, so that's the key thing. Vertically, 0.25. So then y, above the x-axis, vertically 0.25. Now it is reflected in the y-axis and translated 3 units to the right. Write the equation of the new function. So first of all, we have it stretched vertically by a factor of 0.25. So y goes to 4y. Okay? Now we also know that it is reflected in the y-axis. So then x goes to negative x and translated 3 units to the right. So x goes to x minus 3. So if I was to graph this, write the equation of the new function, I'm going to have 4y is equal to, I'm going to have negative x to the 3. Then we're going to put in this one. So I have y is equal to 1 over 4. And then we have negative, bracket, x, subtract 3. And that is all cubed. Now this negative, I could cube both of these, the multiplications. So this will still end up cubed, so I get negative 1 over 4, and I'm going to have x subtract 3 cubed, right? Because negative this here is the same as negative x cubed. So essentially, I could take out this negative, or I could do it later. It's up to you as to when. All right, now the next one here is, we're given this graph here, and I'm just going to start you off for this one. So our equation is in this form here. So first of all, I have 1 over 2 and then plus on the inside. So I'm going to simplify this equation. So we get y is equal to f of 1 over 2. And I'm going to factor out that 1 over 2. So I get x plus 6. And then I'm going to subtract 8. Okay? So if I'm going to do this now, I know I have a horizontal stretch by a factor of 2. So everything's stretched horizontally by a factor of 2. So this is going to go over there. This here is going to go over there. This here is going to go here. This here is going to go here. Okay? So my new graph is going to look something like this. Okay? And then what I have is I move 3 to the left, or 6 to the left, So everything's moved 6 to the left and 8 down. Okay, so let's move the 6 to the left, which this point goes there. This point here is moved 6 to the left, which gives me there, and right there. And then we also have to go 8 down, so this is going to give me right here. 8 down is going to give me right there. This point here, we go, how much was it to the left again? 6 to the left, which is right there. 8 down, which is right here. And this one again, 6 to the left, which is 1, 2, 3, 4, 5, 6, something like that, and 8 down, which is going to be around here. Oops, around there or something. Okay, so then we connect my points, and my points are, then we connect those new points, and that's what we should get. We're going to get something that looks like this. And, oh, hold on, something that looks like this, because this went on for there, and then we go up to somewhere around there, something like that. So that's what my graph is going to look like. Okay? Now, let's take a look at this next part here. The function of this is transferred to that. Complete the statement below. Well, first of all, when I do this, once again, it's non-proper form. It's equal to, because we want it in this form. So I'm going to have -2 square root. I'm going to factor out of 3, so I have x minus 4. And then it's plus 5. So the function has been transformed by stretching the horizontally about the y-axis by a factor of 1 over 3. Then, stretching vertically about the x-axis about a factor of 2. Reflecting in the, well, it's right here, we're reflecting in the x-axis. And translating up, how many units up? 5 units up, and 4 units to the right. So that's everything. Hopefully you understood this as we work on these together in class tomorrow.